So like I said, yesterday was your introduction to just the polar grid, polar idea of what are polar coordinates, and working back and forth between the two. Okay, polar coordinates versus rectangular coordinates. Same idea today, except now we're going from coordinates to equations. Every equation that you basically have always been used to has been in a rectangular equation, meaning polar coordinates had x and y as terms of the ordered pair. Rectangular equations have x and y in the equation, just like you normally would have. Y equals x squared. Y equals 2x plus 1. Y equals 3 to the x power. Okay, whatever. Those are the equations you're used to. Today, we're going to work back and forth between polar versus rectangular, okay, but with equations. So if you take a look, here's the first part. To change from rectangular equations to polar equations. Okay? To change from what you're used to into what we're now trying to get you used to, the polar idea. Okay? Here's the concept. We are going to get rid of the x's and the y's from the rectangular and instead put in r's and thetas. Okay? So we're kind of making substitutions today. There's going to be a lot of substitutions is the idea. Get the x's and the y's out and let's change them into r's and thetas. And ultimately, you want your final polar equation to either be in r equals form or r squared equals form. Okay. Take the x's out, take the y's out, and like I said, we're going to end up substituting in so that we have r's and thetas instead. And ultimately, the number one thing you're going to do in order to do that, remember, we're going to use those two equations. That x is really just r cosine theta, and y is really r sine theta. So these equations, this is where we're going to go from x into r and theta. We're going to take the x out and put r cosine theta in its place. We're going to take the y out. We're going to put r sine theta in its place. We're going to be making substitutions is the idea, so that we can go from one version to the other. I'll let you finish writing, and then I'll give you a couple of examples. The rectangular to polar is usually, if I had to say there's an easier one or the other, rectangular to polar is usually a little bit easier to do. Okay, polar to rectangular is a little bit more difficult. All right, so here's the idea. So here's example number one. Okay, straightforward type of example. Here is an equation that is in rectangular form. X equals 3. Okay, and this could be any equation, but this one in particular is just a vertical line at x equals 3 is the idea. We're going to change that into the polar form of the same thing using exactly what we just talked about. We're going to take the x out and we're going to substitute r cosine theta in its place. Okay, so instead of x equals 3, we're going to have r times the cosine of theta equals 3. Take out x and substitute in what it's equal to. And now, like I said before, when you're trying to finish this off, what you want to do is you want to get it in either r equals form or r squared equals form, depending on the problem. Well, if I want it in r equals form, how do I get r by itself? Divide by the cosine of theta. Yeah. So we're going to divide that cosine of theta out of there. Those will cancel. We get r equal to, and now just a quick heads up when you're checking answers, what they're going to have for an answer when you get to like your assignment and things along those lines. They're not going to leave it as 3 over cosine theta. Instead, what they're going to write this as is 3 times the secant of theta. Where's the secant of theta coming from? 1 over cosine. Okay, this 3 over cosine is really, if I bring that 3 out front, this is really 3 times 1 over the cosine of theta. That's the same thing. 1 over cosine is secant. And here's the exact same equation as x equals 3, but in polar form rather than rectangular form. Okay? Like I said, main thing, any x's and y's, substitute those out and put in what they're equal to in the polar version. Okay? Let me give you another one. There's example number 2. X times y equals 2. So again, some random rectangular equation, x times y equals 2. In order to put that into polar equation, substitute in what x equals, substitute in what y equals. Okay? So if we take x out, x is r times the cosine of theta. Y is r times the sine of theta. Still equal to 2. Okay? So we took the x and the y out and substituted in the polar equivalent to those two. And now we start to kind of clean this up. We're going to try to get, like I said, try to get it into either r equals or r squared equals. If I multiply these two things together, there's not a lot that I can do, but I can at least multiply the r's. So we get r squared times the cosine of theta times the sine of theta. And now, similar to example number 1, if I want this in r squared equals form, we can just go through and divide out the stuff that I don't want. So I'm going to divide everything by cosine theta times sine theta. Those will cancel. And we get r squared equal to, anybody tell me what we're going to write our final answer as? 2 times secant theta times cosecant theta. Yep. Since both cosine and sine are in the denominator, we have secant theta, and then we also have cosecant theta. Okay. And there's your r squared equals equation. Okay. Any questions on that? Any questions on that idea? Yeah. Area. No, I don't believe so. We're basically where we're headed is, yesterday was coordinates, today's equations. Where we're headed is we're going to start graphing different types of different polar equations and see all the different things. That's what's coming up next, the rest of the week. But I don't believe we're going to find the area. Okay? We're doing, yeah, we took out some of the stuff that was done previously. We're taking some of that out. That is only necessary, that was only in because of like Calc BC. So we're taking some of that. We're doing kind of the main ideas. All right, let me stop for a second. Anybody have questions here? Basic idea, take the x's and the y's out, substitute in, and go from there. Okay? Let's go the other way. Here's the one I told you is a little bit more difficult. In order to change a polar equation into a rectangular equation, okay, go in the opposite direction. So if you have r's and thetas and all that kind of stuff, and you're trying to get back to the x's and the y's, trying to get back to what you're used to. First off, we're reversing the process. Okay, you got to be a little bit more creative on this one. That's what makes it a little bit more, it's not as straightforward on these. That's what makes this a little bit more difficult, this version. But when I say reverse the process, what I mean by that is we need to get rid of the r's and the thetas and get back to the x's and the y's. Okay? And that's that process, even though it sounds pretty straightforward, that's the part that's not as straightforward when you do it the opposite direction. Get rid of the r's and the thetas and put in the x's and the y's. And ultimately, we're going to come back to these 4 equations. Here's your relationship between thetas and r's and x's and y's and all that kind of stuff. We're going to come back to these 4 equations. So when you make your substitutions going the opposite direction, the number one thing you'll see this in an example, but the number one thing that you have to take a look at is first, what am I trying to get this equal to? You have to kind of look for, do I have r squareds? Because if you do, you can take r squareds out and substitute in x squared plus y squared. Okay? Do I have r cosine theta? Do I have r sine theta? Do I have just theta? Okay? Things like that. You got to kind of look at the problem on what you have before you start it. It's not one where, I just go and I do this. You got to kind of think about it before you get started on this one. But it's all going to come back to these 4 equations. Okay? So if we take a look, here's your example. Here's your first example of going the opposite direction. So if we start with what I was just talking about, if you look at this equation, and we have to try to get rid of r, and we got to get rid of theta, we got to get back to x's and y's. Let me go back to this one. Which one of these equations are we kind of close to? Which one do you think we're going to try to get to here? X equals r cosine theta. Because if you notice, we've got an r and we've got a cosine theta. So we're close to that. Okay? So that's the first thing you need to be able to do on these problems, is kind of identify that. Now it's, how do I get that r cosine theta? Well, I can't really divide by r. That's not going to work out real well. Okay? So what we're going to do in this problem, I'm going to take this and I'm going to multiply everything by r. Because I want to get r cosine theta. Well, when I multiply the first part, we get r squared. When I multiply the right-hand side, we get r times the cosine of theta. And now, it's about making some substitutions. What do we say r cosine theta equals? That's just x. So I can pull the right-hand side out and substitute in x. What's the left-hand side equal? Yeah, that's your x squared plus y squared. There's another equation we ended up with. X squared plus y squared is r squared. So I can also take that out and substitute in x squared plus y squared. And now, at this point, we got rid of the r, we got rid of the theta, we're back into rectangular form, just having the x's and the y's. And at this point, just as a heads up, when you check the answers, you could stop here. Okay, you could perfectly fine. Matter of fact, I'm going to stop here. But when you check the answers, sometimes the answer key, they may take that x and subtract it over and then it equals 0, just as a heads up. They might rearrange the equation a little bit. Just be aware of it. It's not something that you necessarily have to worry about. But just be aware of it. If you get this, but the answer key says x squared minus x plus y squared equals 0, or some version of that, recognize that those are the same thing. Okay? I'm perfectly fine with you stopping right here. X squared plus y squared equals x. Okay? Everything else is just because. There's not a real great reason to do it otherwise. Questions on that so far? The hardest part of this one is, like I said, what makes this more difficult is recognizing that first step. That, I just need to multiply everything by r and then I'll have some things that I can substitute. Okay, that's the hardest part of these problems. Okay. Let me give you another one. Here's another polar equation. Theta equals 5 pi over 6. So same first question when you begin this. If that's what's given, which equation am I going to be working with out of the 4 that we went back to? If you take a look at these 4, Any idea? Why the tangent one, Flynn? Okay, that could be part of it. Go ahead. It's what? What don't I have in this problem? An r. I don't have there's no r in this equation, which means let's try to get the equation that doesn't have an r in it, because all the other ones have r in them. So let's focus on that tangent equation. So I don't want theta, I want the tangent of theta. How do I get the tangent of theta? Just take the tangent of both sides. Yeah. So in this case, if I take the tangent of the left-hand side, we get tangent of theta. But anything you do to one side, you got to do the same thing to the other. So I'm going to also take the tangent of the 5 pi over 6. So we're just taking the tangent of both sides of the equation. And now we can start making some substitutions. What do we say? What does tangent of theta equal? That's y over x. That was from that equation. So I'm going to take that out. I'm going to put y over x in its place. Equal to, the nice part about the right-hand side, that's a unit circle value. What is the tangent of 5 pi over 6? Yep. -1 over the square root of 3, which you could rationalize the denominator, but you really don't need to. And again, you could stop right here, because you got theta out, you've got x's and y's. However, this one, I'm pretty confident on this one, that the answer key would not leave this like this. They would clean this up a little bit. If we were going to try to clean this up a little bit and try to get like x on one side or try to get it to an equation that doesn't have fractions, what would we do? You could multiply both sides by x and then multiply by, you could clean it up. Or since it's just one fraction equals another, couldn't we just cross multiply? It's just a proportion. So if we cross multiply, we end up with the square root of 3 times y, that's one diagonal, equal to the other diagonal, which is -x. And now you could leave it like that. It's a little bit cleaner than the original one. That might be the answer that's on the answer key for the worksheet today. Maybe they take the x and add it over to the other side and set it equal to 0. Okay, that's another option. But this is the general idea, is we're trying to get those out of there, okay? So number one thing, really what you're doing is you're just making substitutions back and forth. It's just harder to recognize the substitutions when you're starting in polar coordinates or polar equations. Okay? Making some sense though in general? Because I don't want to overcomplicate this necessarily, because it's complicated enough, so I'd rather leave it at that and give you a chance to work and ask some questions and stuff and see where we're at. Okay? All right, let me hand out the worksheet for today. Just a quick heads up coming up, and I've got all these problem numbers circled so you don't have to write this down or anything. But just a quick heads up on Thursday. If you have colored pencils, bring them, and then make sure you have your calculator as well. We're going to be doing some calculator stuff, and we're going to be doing some stuff with these polar equations and kind of checking out all the different shapes and stuff that can come up with this. Let me give you this. I got to mention something about the assignment, and then you can work away with the rest of the time.
Oh, good deal, Mr. Big.
Thinking about you here.
It's really nice.
Certainly problems for you. Just a quick heads up on the assignment. Take a look at the worksheet I just handed out. So all of these problems that I have up here are circled, so you don't have to worry about that. They're all the circled ones. Now, quick heads up, if you take a look at the worksheet, if you look on where the problems are, notice there's some stuff that's underlined. Those are the answers. Okay, so like on problem 43, the answer is r equals 3. You need to show me how you get from x squared plus y squared equals 9 to r equals 3. You need to show that process. Okay, same thing on 45. The answer is r equals 4 cosecant theta. Okay, so you have the answers. That's why they're underlined. They're not part of the problem. The other answers, when you get further in the problem, they're on the left-hand side there. 49 through 76 that are on the left-hand side, those answers are. And one quick heads up on number 51. Notice there is an answer there that's not underlined. The reason I did not underline that is because I don't want you to use that as the answer. Okay? It is an answer, but it's not one that's going to make sense. That's why I didn't underline it. Do that problem similar to what we did with in the example. Okay? And we'll talk about the answer then tomorrow. But ignore the answer on number 51 that's there. That's why I didn't underline it. Okay?
Okay.
And you got the rest of the time to get some work done.